Good morning, everyone. Respected principal of our college, beloved and respected resource person, Mr. G. Tirupati Rajan, respected my friend, colleague, controller of examination, Dr. R. Palaniyappan, my colleagues and friends, Mr. Prem Sankar, Mr. Karthikeyan, and all the participants. We are all waiting here today for the webinar, Enterprise Service Bus Architecture for COVID-19 Data Exchange. Our resource person, Mr. Tirupati Rajan, is currently working as a CEO and the Chief Architect of Maha Data Solutions Incorporation, Raleigh, North Carolina, United States of America. He has completed his studies during the year 91-93. His work experiences, he occupies various architect positions in USA states, government, Medicaid projects for the past 22 years. He worked in the state governments of America, Nebraska, New York, North Carolina, and Virginia. Also, he worked as a lecturer in the Department of Computer Science of VHNSN College, Virudhunagar. Then he worked as a software engineer in Square D Software, Chennai. Then worked as a software engineer in Information Management Resources, Bangalore. During his working period, he has implemented the nation's largest Medicaid program for New York, and the program is still running even after 15 years. For the project, he has been awarded with Presidential Award in the Computer Sciences Corporation of America. He has implemented critical North Carolina Medicaid program and got the appreciation award from governor. He has implemented nation's first Medicaid module, Encounter Processing System in Virginia. Federal government appreciated and suggesting other states to use this same module. He has worked as a performance engineer to tune the long-running programs. One of the pharmacy module, real-time transactions were running for more than 15 minutes, but that module was expected to execute only 5 minutes. When he take over the charge, he improved the performance and able to achieve less than 500 milliseconds. Also, lot of learning program was tuned and rewritten by his software development period. One of the daily job was running for more than 28 hours. Because of his work, it was tuned to run within an hour. So this much caliber he is having. We are proud to say Mr. Tirupati Rajan is alumni of our department. Now today he is here to give the talk in the webinar, Enterprise Service Bus Architecture for COVID-19 Data Exchange. On behalf of VHNSN College Computer Science Department, I welcome the resource person, our friend, Mr. Tripudarajan to take the person. Welcome, Mr. Tripudarajan.
Thank you, sir. Let me present it. Can you see my screen? Hello?
Yes, yes.
Yeah,
Yes,
so which screen you are seeing? The enterprise service bus?
Enterprise Service Bus Architecture.
Sure. Good morning, everyone. I think for you it's a morning. For me, it's like pretty much it's a midnight. I'm glad to present this session to you all. I hope you all going to like it and understand enterprise service bus and how it can be used to collect the data in this pandemic COVID-19 period. The biggest challenge in our world is we need to have a program which is to collect the COVID-19 data, and it has to be exchanged between multiple sources or multiple destinations, and then that data has to be distributed to proceed the either the COVID-19 data services or fix the patient's issue or send any other information to the multiple departments. That is very critical. So in a typical project environment, it will take at least 6 to 9 months to implement any projects. But in this pandemic world, pandemic time, we cannot wait for 6 to 8 months. Everything has to be done quickly. So we are in the process of implementing the solutions in within a day or sometime within a couple of hours. This system has to up and run so that the data will be exchanged. For example, we need to know how many beds are available for the patients. That data is very, very important so that that data can be sent it to the appropriate departments so that they can allocate the beds and they will send additional information to add more beds into the hospitals. It depends on the area. So this data exchange is very, very important. So in a typical programming world, like, if you want to write it in Java, or if you want to write it in Python, or if you want to write it in some other programming language, it's going to take a lot of time to debug it and test it and then implement that solution. So what we like to introduce it is an enterprise service bus, which is more kind of already predefined plug and play. So if I have to send the data from one place to another place, those are all already predefined in the service bus, so that you don't need to worry about, writing a Java code to retrieve the data and send the data and marshal the data, unmarshalling data. All those things are all going to be done in the enterprise service bus, which are all already predefined, and it's like a plug and play. So let's go through this introduction session first, and from there we will see how enterprise service bus will help to collect the data. Before moving to the concept or the enterprise service bus, I like to touch a little bit on the basic concepts. And you'll be wondering, like, why we are studying these basic concepts in the computer science. Believe me, like, I studied these basic concepts in 1989, I believe, so when I was doing my BSc Computer Science in the VHNSN college. I'm using the same basic concept day to day life when I'm designing or architecting a solution. These are all I have to keep in mind and then solution it so that it can be appropriate for that particular solution, so that we can improve the performance, we can send the data faster, and also process the transactions quickly. And then we'll look into the simple healthcare application, how it is going to help, um, how we can achieve the connecting these healthcare applications through enterprise service bus. And then let's take a look into the enterprise service bus, and then we'll look into the integration, how to integrate the multiple applications. And then we will see the sample data collection flow. And then another one is the analytical reporting. That's also very important. And then we have a small demo. And also, you are all going to help me to send some information through the email. So get ready with your emails. So I will give the instruction on how to send that email. If you send that in a particular format, then we'll see how that is stored in the system. Am I audible? If I'm not audible, please let me know. Um, Data structure, basic concept. You're all, I love data structure and algorithm. That's my favorite. So without the data structure knowledge, you cannot store the data and you cannot retrieve the data and you cannot process the data. So the data structure is a very important concept. So what is the data structure? It's an organizing the data for efficient computation. It is very, very important. You need to know when to use array, when to use matrix, when to use the queue, when to use the graphs, and when to use the trees. I hope you all remember all those things, queue, tree, arrays. So let's see what are all the different data structures. The array, binary tree, graph, linked list, binary search tree, matrix, stack, heap, tree, queue, hashing, and tree. Maybe this tree is the retrieval process. Mostly it is used for the Google search to retrieve any data. So today we will use the array, queue, and tree to structure to get the COVID-19 data. You all know what an array is, and let's take a look into the queue. You all know queue is first in, first out. When you push the data into the queue, um, the, whatever the data is pushed in, it will be retrieved on the other side. So what is the disadvantage of the queue? Once you push the data and then if someone retrieve it, the data is gone. So that is the one drawback in the queue. Let's take a look into this tree. You all know about the tree. It's a hierarchical structure. Each one will have the tree will have a root node, parent, and children, and then it can be any number of children. So in this case, we are going to create the hierarchical structure of a COVID-19 record, and that under that it's going to have a source and patient and region as the children, and then the source, it will be a source type where this data is coming from, sender email, and then sender name, and also patient, the patient name, patient age, region, which city and which district. This is the structure that we are going to capture today. And is this a binary tree? No. Binary tree will have only two children. So we have seen the queue first in, first out. We also saw that the disadvantages is when the data is pushed, when some consumer consumed the data is gone. To overcome that, there is a new concept that is introduced called PubSub, which is a publish and subscribe. So what's that mean is underlying the data structure used in this is queue, but how this queue is different, this PubSub model is different than the queue. Here in the queue, you can subscribe to the queue. So, for example, you all know that Twitter, right? There you can subscribe or follow that Twitter. So when the message is posted, until you consume that messages, these messages will be there. Once whoever subscribed and that messages are all there, then it will be stopped there. Like that, in this queue, it have a different channels. So if you have like a thousands of subscribers, that data will be kept in the queue until everyone consumes that. So that is the difference on the queue. But again, the basic concept is used in that PubSub model is queue. So the simple example for that is, let's say if someone identify the patients, the COVID-19 patient, and if they pushed into this queue, then the subscribers, who are all the subscribers to that queue, for example, the hospitals, the health departments, the finance departments, and then where they are going to keep that the health records. So everybody can subscribe that. The advantage is there is a message pushed only once, and then rest of the subscribers, everybody will get that data immediately. So that way, the message is not lost, and everybody will get the message quickly, and also they will react from that message. So this is very important. So this PubSub model is also another model which is used to send messages to the different subscribers. There are so many software available for these PubSub models or queues. IBM MQ, Rabbit MQ, Kafka, Amazon SQS. There are so many other queues are also available. Today we are going to see the IBM MQ, which will have the PubSub model and also has the default message queue also. The second data exchange is the REST API. This is a very important in this era, because the REST API is evolved recently, and it's kind of like, create once and use it for multiple purpose or multiple resources. So there will be only one function, but anybody can invoke that function from anywhere. So if you see this, the API COVID-19, then anybody can retrieve that data from web apps, car or enterprise applications or mobile device or sensors or any watch, TV, game, anything you wanted. So you write once. So REST API is nothing but it's a function. You all know the C language functions and all those things. So there's some function, find the factorial or find additions or find some combinations or random number. So anything you can call as a function. So those functions are all going to be written once, and it will be invoked by anyone. So simple example I like to give is the weather. So, for example, if you want to find the weather of Virudhunagar, then all you need to do is invoke this REST API, whoever is that producer is, and all you need to do is invoke the REST API. Then you will get the weather of Virudhunagar, or you can get the weather of my area in Raleigh, North Carolina, anywhere in the world. The advantage here is there is only one person who is really collecting the all the weather informations, and then he's distributing it to everyone. Not distributing, and by invoking that REST API, anyone can get that data, so that the actual function is in one place, but it will be used throughout the world. If you see that now weather access is very common. Nowadays, everybody look for, hey, today it's going to rain, or what's the weather? It's going to be 90 degree, or it's going to be 90 degree Fahrenheit. We are in a Fahrenheit, or 20 centigrade. What are all the things you need? Everything is going to be as a REST API call. In TV also, that's what they are doing. Is the TV station doesn't even have a whether they are setting up in each and every town, and then they are collecting. They are not collecting like that. It's just they invoke the functions. Whoever is providing that, just invoke that and then show it in a visual form. So what is that REST API? It's a representational state transfer. It's all on the HTTP based. So it's like a web page. You can invoke it as a HTTP, and if it is an secured, then it won't be HTTPS. And then you can get that data in a JSON format. JSON format is very famous recently. You all know XML format, and then the JSON format is the JavaScript object notation. It is nothing but a value pair. So you can say name colon Raj, something like that. That is a JSON format, which is a value and then name and then value. That's all called the JSON format. I will show you the JSON format example. It is one other advantage is this function can be written in any language, but it can be invoked from any other language. So let's say the function is written in Java. You don't need to be invoke that function in Java only. No, with a REST API, you can write that REST API function in a Java language, but once you publish it, it can be retrieved from any other programming language. So that's the beauty of this REST API. The Google also provides a lot of APIs. You can Google it and then find all the Google APIs. So so many Google APIs are all available. And if you want to learn REST APIs, there's a website called restapitutorial.com. You can get that information. Here is the REST API example. So this is, I said, like a value pair, say state colon NY, and then positive these many cases and negative these many cases, hospitalized currently 3436. So these are all like a REST API. For example, I can find the, let's say this is an API which is in North Carolina. This is published by someone who is collecting all this information throughout the nation, and then they are exposing this REST API. So I can invoke this HTTPS colon covidtracking.com/API v1 states and see, then I will get that data immediately. So for example, all I did is click, this is the HTTPS, the REST API, you got this data. So this is NC. Now it's saying total positive cases are 77,000, and then negative cases are all almost 100 and, sorry, 1.1 million, 1.01 million. And then currently 994 patients are hospitalized. So these are all updated immediately. All I need to do is just invoke this HTTPS function. Somebody is posting it, so I will take this one, and then or anybody can take this resources and then act quickly. How many cases are available? If it is a hospital sees this, then they will try to understand, okay, these many cases are all there, and then how many already hospitalized and how many is needed, more beds are needed. They can react quickly. So these are all current data. I think 7.9, if I put it, I may not have it yet. Yeah, 7.9 is not there yet because we are still in the Wednesday night. So 7.7, you will get that. So each state you can get that. This is called REST API. So also, there is multiple states. So if you see this one, each state will have all this data. So just click a button, you will get the entire US states status of how many cases on each state, how many positive, how many negative, All those things will be retrieved through this REST API. Okay. Next data exchange is the file transfer. File transfer is a typical file-based data exchange, which is very normal because you will send it in an Excel spreadsheet, and then you upload the file to Google Drive or Microsoft OneDrive or Amazon S3 bucket. Any of those things, you will upload the file, and then somebody can download the file, and then that file will be used for processing. This is a typical file transfer. The languages mostly, nowadays is using is Java and Python. Python is going really crazy on this. Everybody is now talking about Python, and it's very easy language also. I remember that when I was doing basic computer science, there was basic language was there. After some time, basic was gone. Now Python is there. Pretty much, kind of like basic language, and then Java. Let's look into the data exchange between applications. This is very important. So let's see healthcare applications in the patient's record, how to track and how to recover the patient, or how to treat the patient. All those things are through the application. Different applications are all there. So let's see the scenario. Patient is sick and he is visiting the doctor in the clinic, and then doctor requesting a lab or X-ray, and then the result has to send back to the doctor, and then they are identifying the disease, and then depends on the disease, the information has to send to the immunization record, and then patient has to send to the hospital, and then hospital send the prescription to the pharmacy. These are all some small application there. I mean, small healthcare application interactions or use case. So now let's look into that different applications. Patient record is written in .NET, and then doctor details applications are all there in VB, and imaging is all in a different language. Hospital application is in Java, and then pharmacy application is Python, and immunization record applications in C++. So here it is kind of like organized. I think in now India also most of the hospitals are all tracking all those things, patients' information, so that it's easy for them for the doctors to treat. So, for example, if a patient goes to the doctor asking him to go and take the X-ray or go and take the CT scan or the other lab request. So how do you know that that patient really went to the lab or took the X-ray? There's no tracking. Sometimes what patient will think like, no, oh, yeah, let's forget about that. That's going to cost more, and let's go away. So the tracking is very important. They lose the tracking. The same thing. If someone is identified as the COVID patient, if they are not telling someone, then nobody is going to identify it until we see a more spread on it. So it's very important to track the patients, and also what happened, and all where they went. Those all has to be captured in an applications. And now think about that. These are all in different application. How do I connect this? How this patient record is in .NET, and how to send this to VB, how to send it to C++, and how the data is going to be transferred or communicated to the Python. This is a challenging. And also, let's see that what are all the possibilities of connecting these applications. This is the way it is going to be connected. For example, patient record. This can talk to the doctor details, and then this can also talk to the immunization, and then pharmacy can talk to the patient record and the imaging, and then pharmacy can talk to the hospital. Think about that. How many different connectivities are all there? And now, if one connection is broken, then we lost the tracking, and also we don't know what happened, and it's going to be very difficult. And also, if this application is changed, then it's going to be very difficult to communicate to each and every applications. So, how to resolve that? That's where the enterprise service bus comes in. Enterprise service bus is nothing but a broker So see the difference here. Each application is communicating directly to that application, I mean direct communication. But with the enterprise service bus, these application won't talk to each other directly. It will go through this broker. So what it does it, when the data request comes at .NET or any REST APIs, this enterprise service bus will know, depends on the data, it will route it to the appropriate applications, because the enterprise service bus has its own way of converting the data or connecting to the different applications. So that's the beauty of this enterprise service bus, which is, all in one. You can call it as like a all in one. So that those are all predefined adapters or connectors are already available, so that we can easily connect these applications and the data will be sent quickly. So mostly it's used for the protocol. It can be any protocol, TCP/IP or HTTP, HTTPS, any of those protocol. And then data format, any data format, data exchange, you name it. Queue. If you want to send the data in a queue, you will send it. If you want to send that as a tree structure, you can send that. And if you want to send that in a REST API, you can send that. All those things are all in that. Error handling, it handles that. And also monitoring, that's very important. So let's say a patient, let's see the doctor, doctor writes the prescription, then it can be directly send it to the pharmacy, and then pharmacy will send the request, send the response back to the doctors saying that I filled that prescription, so that at least we know that the prescription is uh, filled or not. The only drawback here is there is, if the patient is not taking that medicine, then it's not going to be uh, communicated in this. That's the one caveat into this one. But doctor can also identify back by sending that into the lab, saying that every 2 days measure the blood work or the urine test, so that we will monitor that the patient is really taking the medication or not. So that's also we can communicate or we track the status of that patient, monitoring, and we can monitor all those things. All audited, auditing will be there, and who sends the record, what time and where it went, and what all the values are all captured. We can capture it in the enterprise service bus. Okay, so enterprise means is a corporate level. For example, if you want to have like a university, Madurai Kamaraj University as like a whole university, you can call that as a corporate, and it can be, they can have an enterprise service bus. And then if each college wants to communicate different informations, they will communicate through the university, and then it will be dispatched to the appropriate colleges. Any information that is needed, or any marks, or any subject related, everything can be communicated to the university, and the university will dispatch all the data back to the appropriate colleges. So you assume that that's what the enterprise level. And then services, you name it, what are the services you needed, it's all there. It depends on the enterprise service bus. There are so many adapters there, keep on adding that. Main important thing is security. It's called AAA architecture. I think you all know that in a security, I think you are all having a security paper, or some subject you may study that. You will know that AAA architecture, which is an authentication, authorization, and accounting. Authentication means when the user logs in using a user ID password, that's authentication, to make sure that the user ID and password is correct. Authorization is really to understand the whether this user can access this particular page or not. So that's where the authorization comes in. Accounting is who is accessing what data. Mostly, if someone sees the mark from the application or in the university, it will record this person saw this student's mark, or this person updated this student's mark. those all will be accounted and be stored into that, audited and then stored in the database. And then web services, file transfer protocol, and then automation, data mapping, all those things are all done in the service. Monitoring, tracking, protocol conversion, messaging services, and routing, data exchanges. It can be synchronously or asynchronously. Synchronously means I need a data immediately, so you'll get the response immediately. Asynchronously, I will submit the request into the queue, and then it can be processed, and it can be sent it back in a leisurely, or it can be sent it later in the night. So that's asynchronously, that I'm not expecting the response immediately. The bus, why they call it as a bus, it's really a pickups information from one system and delivers it to the other. That's what it's called. They call it as a bus. Basically, it's like communication between the software applications and then all in one. So this is another representation of the enterprise service bus. If you see that, this enterprise service bus has analytics also, quality of service, monitoring, security, service orchestration. Also, you see these different file sources. You can send any data in a comma separated file or Excel spreadsheet or PDF file or whatever that you can send it, and then enterprise service bus will consume that. And then events and messaging systems is like mostly like queuing, like we saw that pops up method. So you just publish it, and then the enterprise service will, through the enterprise service bus, you can consume the data. Any subscriber can consume that data. And these are all cloud services, of course. So enterprise service bus can read the data from the Twitter, and it can read the data from the Facebook, and read the data from Amazon or Google or in anything, PayPal. All those things are all having a connectivity there. So, for example, if I want to read Twitter, I'm going to create the Twitter, and then someone is responding to that Twitter or retweeting it. All those things can be captured in this through the enterprise service bus. You don't need to write like thousands lines of code. It's like just plug and play. Same thing for Facebook. Why do we need this Facebook and Twitter and all needed for this? In this scenario, for example, so I'm hearing a lot of stories in what's happening in Tamil Nadu now. So if someone is having a COVID, and if that message has to be conveyed to a appropriate department, so department can have a Facebook page or the Twitter account. They can then anybody who is who knows or who find out that his neighbor is having a COVID or something like that, they can inform or they can tweet that to that Twitter account. Then this enterprise service bus can consume that message, and then it can send it to the appropriate department. This is going to really save a lot of people's life, because people are afraid to tell outside whether they have the COVID-19 or not. That is going to be a biggest challenge on treating them, and also it's going to be very difficult to stop the spreading. So through this, it can be easily send it to the either email or Facebook or Twitter, all those things. So today we are going to see. I have set up some email. So if you send the email, and that email will be stored or parsed and then stored into a database, and then that data can be sent to the different departments. That's the application that we are going to see it. Let me do a time check. 12:45. Sorry. What's this? 11, 10:30, I believe so. Okay. What are the enterprise service bus solutions that are available? The topmost one is the MuleSoft ESB. MuleSoft is having an enterprise service bus. They have a lot of connectors. But today we are going to see the IBM Integration Bus, which is the one I'm familiar with that. It has a lot of connectors, but MuleSoft has more connectors to that. IBM Bus is also adding more connectors, and then Web Methods integration servers, Oracle Service Bus is there, Red Hat Fuse is there, Talent ESB is there. Is so many ESBs are all available. So whichever is more applicable and which are the connectors that you are needed it, and you can use any of this. In fact, actually you can use any of those things. These are all like different providers, cell phone providers. So you can get it from any of these the enterprise service bus from different software companies. This is the enterprise service blueprint. It's like, as I mentioned in the previously, there is so many operations are there in the enterprise service bus. It has the operation and managements. In that itself, you'll see so many of them: message tracking, throttling. So for example, you all know the parallel processing. I think you'll be studying parallel processing in BSc itself. I hope so. So, what is that parallel processing? For example, if for processing the file, if it is going to take 5 days to process, now if you are running with one thread, like a one record at a time, it's going to run for longer, like 5 days. How to reduce that? You can use the parallel processing and add multiple threads to that, and then you can run that parallelly. That means instead of running one record at a time, you will run like hundreds of records at the same time, process that, and then you will finish that processing within like hour or two. So I think you will study the parallel processing. um, with the message throttling, you can say, okay, so I got a file and got like 1 million transactions to process. Then you can set the throttling parameter. Say, if I see these many transactions, run 1,000 threads. It will automatically run the 1,000 threads, and then it will execute parallelly, and then it will coordinate each other. And one thread is completed, then it will automatically start the next thread. Like, it's all handled in this operations and management. It's pretty sleek, so we don't need to worry about how long it's going to run and how. And 10 years ago and all, this ESP was not there. You have to write a program, Java threading language. Java, you need to add the multi-threading concepts by ourselves, and that takes a lot of time to test and all those things. But with this ESP, just a couple of clicks, you can set up the message throttling. Load balancing, you'll see the load balancing is if I have to run more threads, and sometime one server is not enough, so we'll add more servers. And then through that, you all know about the round robin method, right? So that first transaction will go to the first server, and the second transaction will go to the second server. Like that, if you set up 10 servers, it will go in a round robin method. So all those things. I mean, I'll point telling you, whatever you study in BSc or MSc or MCA, everything is going to be used in a day-to-day life in whatever I am using it right now. Logging and reporting, error handling, deployment, those are like operations and management, and mediations. These are like a protocol, and the message transformation, message routing. So it depends on the message. If you see the message certain field on that message, then it will automatically route it to the appropriate applications. So we already saw that, right? The different patient record. By seeing that patient record itself, it knows, okay, now it has to go to the doctor application. So it automatically routes to that appropriate application by seeing the data. And then security, as I said, like authentication, authorization, accounting, and then encryption. That's also very important, so that nobody can hack that. Then adapters. This is where is the individual software vendors will provide more adapters. So we have a SOAP, a JMS, email, FTP, EJB, database adapter, third-party adapter, and custom adapter. And then service hosting, mostly in a service container and component model. It has like a multiple components can be defined so that it will be auto scaling. It will scale automatically to that. Next one is the integration bus. This is the IBM integration bus that we are what we are going to see that. So if you see this integration bus, it has a node and then server. All these applications, multiple applications can be run inside that application integration server. Each application is independent of it, and it can also share certain libraries between these applications. And these are all the external system which will communicate to the integration server. This is the whole concept of this IBM integration bus, and the outer surface are all the connectors to connect to the integration node. So it has also web user interfaces, so you can easily set up the number of, throttling, number of threads need to be run. All those things are all done through the either this console or the web user interface. It's pretty solid, the enterprise service bus. Okay. Any questions before I proceed? Okay. Hello, anybody there? Hope you're all there.
We can have it at the last.
Okay, sure. So can you all see my screen, right? Are you seeing now COVID-19 data collection screen?
Yeah, we can. We are getting it.
Okay, cool. I want to make sure that I didn't lost you out. So think about this data collection, how these, I just created some model. It's not real, but it will be good if we have this model. This is some of the sample model. I took it, which is going to be pretty much used in other states also. Let's see that. So, hospitals, nurse or person send a message to the enterprise service bus regarding the COVID-19 patient. So it can be they can send a text message, like through phone they can send a text message, or they can send the email, or they can send the WhatsApp or Twitter, Facebook, any format, or they can send it to that. So you may also most of the TV channels says like if you want to buy this product, send a message, type 123 comma 647, and then send your credit card number. And then once you send it, all the money will be taken and you will be gone, right? But anyway, so you can send any data through a text, email, WhatsApp, and Twitter, Facebook, and that goes to the enterprise service bus. So what it does is enterprise service bus will receive the data, and then data homogenization. Homogenization means like convert into a one standard format, because when you send it to the phone text message, the data what you receive is in a different format, and you need to pass the actual content and then create a data structure for that. And email, how the email, when you send the email, you all think like whatever you are typing in the subject, that is what it's sent in the email. But no, in the behind the scene, it sends a lot of mail messages, and it will have like so many other information in that. So when you read the actual email, um, your Gmail is completely parsing it and then showing only the content to you. But behind the scene is really, if it's an encrypted message, there's a lot of other information will be sent through that, and then we need to retrieve those and remove that headers and footers, and then we will send that data. And then, so let's say, for example, they are sending some patient information and an address, and then where he is from. Then you can do a search patient detail, and then other authentication application is available. If you have a time, visit this https auth.uidi.gov.in/2.0. There you can search the using either other number or using some other name or the address with the street. There are certain way you can search that, and you get that information. And then also depends on where he is, and then find the hospital details, what all the hospitals are nearby, and then store that hospital details and the patient and then hospital details into the COVID-19 database. Also update registries. Registries means is mostly, it's, each municipality or the corporation will keep the health registries. So vaccines, or if something is done, that has to be sent it to the health department, so that they keep the record on how many people are having malaria in that area and how many people are having COVID-19 in that area. They keep that registry, so they send it to there. And at the end, you can do the publish data to the queue. So this is like a sample, like enterprise service bus, how you can collect the data and then store it into the places. So think about that. If Tamil Nadu government has these kind of enterprise service bus, so anyone can send a text message, email, WhatsApp, Twitter, Facebook to see, hey, I have some corona patient nearby, and they are struggling. So just send a message, and it will be send it to the through this enterprise service bus. They will keep track of the record, and then we can also alert that area. Then the data will be published to the queue. So let's see why we have to publish this to the queue. Okay, so once you publish the data into the message queue, these are all the subscribers. So they can subscribe to this COVID-19 queue. Let's say Tamil Nadu COVID-19 message queue. So whoever wants to subscribe that, they can subscribe it, like food department, health inspector, sanitation department, finance department. They will subscribe to that, and then they can immediately take action on, oh, you know what, this patient is coming now, we have to prepare the food for that. And then health inspector, has to measure that area where what all the other people are affected to that, so they can go and look for it. And then sanitation departments, they can go to that particular home and sanitize it, or the whole street to sanitize it. So, and then finance department, all for all these things you need a money, right? So that the appropriate fund will be allocated immediately, and that fund will be distributed to different departments immediately. So think about that. There is only one message there, you published it, and then when you subscribe it, everything will be shared. The data is shared, and then each department will automatically look into that data, and then they react quickly, so that they can stop the spreading, and they can cure the patient quickly. It helped a lot on this. And then you can also use this for the analytical reporting. So why this is needed? You all know that, right? The TV, when you open a TV, oh, now every 5 minutes is a flash news. Like 200 people affected, 300 people affected, 900 people affected. That's where the flash news comes in. Where they are getting it, these are all they will get it once you have the data. So, like, for example, you have it in the COVID-19 database. You will have, you can, like a TV media or web portal, mobile app, or voice call, you can send a request. Same thing, receive the data and data homogenization and find what they are asking. Are they asking like how many patients are all died? Then it goes to the COVID-19 database and get the data, analyze the data, format the data. Why do we need to format it? For example, if you are sending a text message, then the reply has to be in through to the phone. So your reply has to be, the format has to be in the phone text message. That's why we are formatting there. And then if they send it through the email, then you have to format into the email and then send the reply. So this database will help to collect all the analytical reportings. You can also ask, like, show me last month how many patients are there, or show me that how many patients in this today or this week. So those also can be done through this enterprise service bus. Okay, now let's see what is this enterprise service bus is. Okay, so here is the enterprise service bus development. We call it as an integration development. This is the IBM's tool, and it's easy to, as I said, like it's a plug and play. You can easily create a. You don't need to write a code at all. In some cases, you need to write a code. In some cases, it's just a plug and play. So let's see this. This is called the palettes, and it has a lot of plug and play. So let's say um, I want to send or receive an email. All I need to do is uh, click this and keep it here, and then I will say what is my pop three. Let's say pop three. I want to see from um, pop3 dot gmail.com. That's it. And all you need to do is in a security, you have to mention the your user ID and password, your email user ID and password. Once you specify it, boom, that's it. Now, whatever the email, if anybody send the email to you, you will consume that email in no time. You don't need to write a code. What all I did is click this from input, and then I set up the POP3 server address. Actually, POP3 528 is the port, and then security. Here you can mention your security identity, like your user ID and password. And then once I receive the email, and if I want to process it, you take the transformation and then Java code, and then you connect this to, and then this is a small piece of Java code, but most of the time this code will be pre-written for you. So let's see, the email input comes in and then Java code, and all you need to do is write your user code. What do you want to do after you reading the email? What do you want to do? Just to write that code. That's it. Rest of the thing all it will automatically take care of it. So how long it took for me to read the email and then send it to the Java compute and then to process that? It's no time, right? So that's the beauty of the this enterprise service bus. And then let's take one simple example, like a queue. I have a message queue. So input queue, I can say the queue name is input, and then message output. So what I am saying here is I will get the input queue and then move it to the output queue. So let's assume that this is data coming from email, and then that information is published to this output queue. So let's say queue name is output. So now when the data comes in, I will automatically uh, move that data to the MQ output. So this output queue can be subscribed by any number of persons, like different departments, and then that department can consume it anytime. So I don't need to write any code for this. So I have this input queue and then output queue. So there is another option also you can do. So let's say whatever that data coming from the email, right? We have the email, right? So the email input, so I'll submit the pop3 pop3.gmail.com, and then connect to this MQ output and specify like output. So what will happen is whatever that email I receive, everything will be published through this queue. Did I write any code? No. So it will automatically read that email and then it will send it to the queue. So sleek, like you don't need to write a code at all. So let's see a simple queue, how the queue is going to be used. So I have input and then output. So this is the sample queue. So this is one of the IBM. If you see the IBM MQ, these are all the queues. So let's say I will put the test message into the input queue. This is first, something like this. So I place this input queue. Right now, I want to publish this to the output queue so that anybody who is subscribing to the output queue can retrieve my data or the data from whatever I'm sending it. So right now, if you see the queue depth is 1 and then output is 0. Now I wrote this MQ input and then MQ output. All I am going to do is test this queue and then I will deploy this. Now look at that. Whatever I placed in the input queue, it is moved to output queue. Now you can browse the queue. See, whatever it was in the input queue was pushed to the output queue. Now, whoever is subscriber, it can be the subscriber can be anybody, like Virudhunagar municipality or health department or anybody who are all subscribed to that, they will get these information immediately. And now since it's executing it, when I put second message, second patient, then it will be immediately moved to the output, right? So this is the beauty of this enterprise service bus. You don't need to write much code, and it will automatically send this information to appropriate queue. This is one way of communicating that. And then one other thing you'll see that this is the flow that we are going to um, work on this as a demo. So here I'm going to receive the email. So I have an email configuration, which is a POP3 configuration. And then security is also my email security ID, which has the user ID and password. That's it. And then, as I mentioned, there is a data mapping, whatever that data email data coming in, and that data has to be mapped to a the tree structure. You all remember that the tree structure that we discussed about this tree structure. This is the tree structure we are going to store so that whoever is consuming that data can be used in that format. So it's a small code. Um, if you see this Java code, it's a plain simple Bojo Java. All you need to do is it's in a message, it's a root element. And if you see this COVID-19 source patient region, right? COVID-19 source patient region. And that's nothing but COVID-19 and then source patient region. These are all the one. So how I am connecting that is COVID-19 is the um, header. And then if you see that I'm creating the child, you see this out COVID and then out COVID ID dot create the child. The child is source, and then second child is patient, and then third child is region. And then I have the outsource is the child of COVID-19. And for that, I am adding these three children, which is source, sender name, sender email, which is nothing but what we have seen that source, sender, and sender name. So like that, you can create the tree structure in no time. All you need to do is create the header and then child of child. You just create as a tree. And behind the scene, it's all those informations are already there. It will automatically put it into this tree structure. It will put it in this tree structure, tree data structure. It's very simple. And then I'm adding a database connection, create statement, and insert into that data. And whatever the data I'm getting in the email, it will be inserted into this. Okay. Now, also now this is a time to send the reply back to the email. So let's say somebody is sending the email. So you need to acknowledge it, right? Somebody is sending, hey, I have a corona patient in my area. So then if he's sending it, we need to send reply back to them saying, hey, we received the data. So here we are sending it to the SMTP email. And then there I'm sending, thanks for the information. We will inform the appropriate departments. Stay home, stay safe. So I'm just adding a email message to this. That's it. And it will automatically send that email back to that sender. So let's see how this application is working. The database what we are using for now is Postgres. So you all know about Oracle database. This is a free, the open source. It's called PostgreSQL, POSTGRESQL. Pretty much is like Oracle, but it's lightweight and then it's more powerful also. And it's free too. So anybody can download and use it. So there's no license for this too. So right now, if you see this COVID-19 patient, it's empty. So um, the idea is send an email to demo covid19esp at gmail.com. This is a demo covid19esp at gmail.com. But in the email subject, send the patient name, age, town, and district. So, for example, Velan, it's a name, age is 85, and Sivagasi and Virudhunagar district. So you send the email, and we'll see whether it is writing into this database or not. So I will send the email. At the same time, you also send the email, which is demo COVID-19 ESP. I'll show it. This is the email, demo COVID-19 ESB at gmail.com. Let me see whether it's a chat there. But you cannot see it. Okay. So demo COVID-19 ESB at gmail.com. But remember that the format has to be name, age, and you must put a comma after the name and age, comma, town, comma, district. So let me try this. I'm going to compose the email. It's a demo COVID-19 ESP at gmail.com. And then in the subject, I'm going to put Valen 85, Sivagasi, comma, Virudhunagar. Okay. This is just the model. I mean, can be anything, but right now this is the for demo purpose. I have that simple application. So demo COVID-19 ESP at gmail.com, Valen, and age is 85, Sivagasi and Virudhunagar. So I send the email. So let's see what I should get some response. Let's see, and also we'll watch this queue. So the COVID-19 patient queue should be filled. Here you go. See, I sent the email and I got the response saying, thank you, Rajgopal Krishnan. Thanks for the information. We will inform the appropriate departments. Stay home, stay safe. COVID-19 team. So now let's see whether we got the patient. Wow, looks like we got two emails. Um, let's see the database. Okay, here you go. We got multiple. So looks like some two other persons sent that email. So you should get the response also. And let's see the queue, the COVID-19 patient queue. Browse it. So three. So this is the data we receive, and the converted data is. Let me show that in a format, readable format. Here you go. So this is the you send the email, that email message is converted into a JSON format. So the JSON format is also, it's like a tree structure. You see this tree structure. Um, this is the tree structure we looked into that, right? So COVID-19 is the record, and inside that source, patient, region. Those three are the child. You see this source, patient, and then region. Those three are the child, and then under the source, you can see source, and then sender name, sender email, and then patient name, age, and then region, city, district. So this is the format. It will be published to the queue, and whoever wants this data, they will subscribe it, and then they get this data, and then they can do whatever they want. So this is just collecting it, and in this case, what we have done is we also collected the data in the database. Um, So when you are sending email, make sure that in the subject you are putting like the patient name, comma, age, comma, city, comma, district. So if you put it in that format, then you will see the data properly here. Right. So like this is correct. Ganesh Kumar, Ganesh 33, Swagasi, Virudhunagar. So that's the correct format. Right now, I didn't add any data validation and all those things just to show this. I have done this. So you can add more validations to this. So you will see these 5 records in the database also. At the same time, I published this 5 messages to that queue also. So this is the patient queue. And also you'll see the email log queue. Let's see what's in there. So see, this is the actual message which we got it from the email. So let me show that how the email is sending the messages. So this is the way that your email message is sent. Content type multipart, and the binary, and then you have the subject, and then you see so many other data also there. So why I have to log this? This is very important for auditing purpose. So for example, someone hacked the system, and then to reduce the number of patients, they can go and delete it. Then we cannot track it anymore. So to avoid that, we will log that auditing. So nobody will know this log queue. It is going to be under that. So they cannot go and delete this queue because it's going to be mostly read-only queue. Nobody can delete it. So this is an auditing. So if 100,000 people send the email, all those 100,000 email will be captured into this queue so that nobody can cheat on that. So it's like auditing and tracking purpose. It's easy. All I did this is to capture this audit logging. The code was just log email. That's it. All I did is connect this one to the queue. I didn't even write any code at all. All I mentioned is email underscore log underscore queue. That's it. So that message is immediately put it into this queue. Now I have a record of who all sent that email, and nobody can change that one. But this one is a consumer who can consume it. Once you consume it, the data will be gone. But again, this database, somebody can go and delete that also. But still, I have keeping the original log in somewhere so that nobody can cheat it. If someone wants to audit it, here you go. This is the number of emails we got it, and why we didn't take any action on these people. So those all the auditing and accounting will be done in this. Okay, now we got 6. Cool. Okay. Now there are so many. Also, one other thing like a REST APIs, you can invoke the REST API also, um, like a HTTP input, HTTP request. So you can invoke the complete the Corona details, which we looked into that before. Um, let me see that the Corona patients, how many patients are there? Okay, let me run this one. Okay, here we go. This is the one. So this is the REST API. So I got this JSON output, which has the state NC, how many positive cases. So I can invoke this HTTPS, the REST API by just adding like HTTP request on this. Yeah, here we go. HTTP request, and then I mention just that URL. That's it. Once I invoke this URL, then I can store that data into the queue. That's it. And you receive this data, and also you can actually timer. You can set the timer. For example, um, there is a timer. Here we go. So timer notification. So I can say out, and you can say, and then timeout interval. I can say like 300 minutes. So what it happen is every 300 minutes it invoke this REST API and get the data for me. So I don't need to write like invoke each and every time. All I need to set the timer. How often you want it. So 300 seconds. So how often you want it? You want 3,000 seconds. You set the 3,000 seconds, and then every 300 seconds it will invoke this and then update the database. So it's pretty straightforward. You don't need to write any code for that. It will automatically run every 300 seconds and then get the data, and then I can pull the WebSphere MQ and then output. So and then I connect it. So what I'm doing is every 300 seconds I invoke this REST API and then put it into the MQ. That's it. So very simple, and think about that. This is very fast, and we can build this system in one day and collect all the data and send it to anywhere you want it. That quickly you can develop the application, and it will be useful to anybody who in this pandemic. That's what we needed. The data is very important, and it has to be sent quickly without losing it, and then everybody has to react quickly. That's where the problem is coming in. We don't know how to track it, where these people went in. Everything will be captured in one place, and then it can be tracked and then treated, and the corona will be gone quickly. So these are all things are all used in US also. That's where they are controlling it and then more tracking it. The backtracking also very important, so that where that person went, and those are all also captured. Um, so without that, it will be, you will see like more cases. You will be seeing like 10 million, 20 million cases that you will see it. But at least this kind of tracking is there right now, and the food is processed and everything is done. And you won't believe it, like, for the school, online classes were all, also there. And how this was done here is, so the laptop or the iPad or any tablet was send it to the home, whoever is not affordable to have that tablets and the laptops for each students. At least in our Wake County district, that's what is done. And then food will be delivered to the home. And then people who are all in the area where they don't have internet, the school buses were sent, and then from the school bus the internet was connected, and then the online classes were conducted too. So it's so many things can be done through this enterprise service bus. Okay, next move on to the data analytical reporting. So some of these are all the way we capture the data. So what do we do with this data? Now, if I want to see how many patients in Sivahasi, then I can query this data table, and then I can easily plot the graph and show it. And then we can also see what are the age range, then we can plot it. So those are called dashboards. So by using this data, you can collect and send the information in a visualized format, so that the executives or the top level officers can understand that and see the trends. So let's see. This is one of the California State Analytical Reporting. This is in a public, so that's why I'm showing it. In our side, it's not in a public area, so that's why we are not showing that. But California, it is in a public. And these are all tools available for graphical representations. Tableau is the topmost one. So any analytical reportings, Tableau is the best one so far. We can show through the map, like district map, and then see which city or which town has more corona cases, and easily plot that in no time. It's like really faster. You don't need to write a code for that too. And then ClickSense, Zoho, Bird, Power BI, ClickFolio, DataPine, SciFi, Domo. These are all analytical reporting tools. But for this uh, discussion, we are going to use the Tableau. Let's see this California State Analytical Reporting. Here we go. So these are all like, graph, how it is day over day new cases, how this is spiking. See, these are all spiking now. These are all real data, not the dummy data. This is the California department producing this. And also county. County means is a district. Like in India, it's like a district. Tamil Nadu is like a district. So each district you can see who is having a lot of cases. So when you click this Los Angeles, you will see that district has um, this many cases. And then you can see what's the percentage. Female as a 49%, and then male as 50%. Someone unknown, which they are not revealing that. And then age range. 0 to 17, 8%, 18 to 49, 59%. So we will, by seeing these ages, you can easily plot it like, what are the percentage, who is getting more. In this scenario, if you see that 18 to 49 is more, that's really weird. Like we initially thought like 50 to 64 age is more, but nowadays it's getting more on 18 to 49 ages also. and then ethnicity, who are all having more. Mostly in this area, Latino is getting more. So like this, easily you can find the graphical representation of where it's happening, what are all the things, how many deaths. Look at this, how it's trending. You see this? It's going up, down, up, down, up, down, up, down. That means some pattern they can see. Is that happening in the weekend or is it happening in the weekdays? Where it's happening and what's happening? By seeing this graph itself, you can see the trend and understand what's going on, and then see the testing results also. So this is so many, it's all graphical representations, and it's easy to understand. By seeing this table, you collect the data, but seeing this table is better than, sorry, this graphical representation is better than the just seeing this table data. And next one is I use this COVID-19 update worldwide, and this is pretty much they are using REST API, and it has a pretty good information. This is um, the active cases so far and the closed cases and daily new cases, how it is going. This is a world device. But at the same time, you'll also see the USA, Brazil, and India. So these are all like a topmost now. And if you click the USA, and it will give you individual state wise, each state wise how much it is. Um, and then New York, if you click it, you can see individual district wise. Everything is collected and everything is through the REST API only. So one person is collecting, and then rest of the team is just displaying in a way so that it is easily understandable there. And then India also, I think, has it. Okay. And then in India, there's a one person is maintaining this. I forget his name, Anuj Arora, I believe so. So he's doing pretty good job on this. I'm not sure where he's collecting it. It may be collecting somewhere, but he's also having the REST API. So far, these are all confirmed cases. And then I think they are using Tableau also, because as I said, Tableau is pretty good. Now, this is the India map, and if you click this state, and it will give you the state level information. So let's see Tamil Nadu. Okay, let's click this. Now, as of now, the Tamil Nadu, the confirmed cases are 122,000. That means 1 lakh 22,000. And active, and then recovered. And then if you see Kerala, Kerala is only 6,000. Wow. And then this is Maharashtra, which is highest one. So you can click the states and then see um, what is their statistics. So these are all easily plottable. All they are doing is reading the data from the table, and then they will bind it to this map. And then when you click it, it will automatically show that the appropriate counties on this. And then they have the trend also. During the lockdown, looks like it is all like increased more. I don't know why it is. Let's see the Tamil Nadu, how it is. Yeah, here also it's going up. So by collecting this data, you can do a lot of things and track it. Um, yeah, it's a Tamil Nadu. Okay, that's also going on. So this is one of the analytical reporting, which were captured. So the idea is one place you capture the data and then it's distributed, or whoever wants to collect that, or whoever wants to get that information, they will subscribe to that and then get that data. It is shared between multiple resources, and then quickly shared to appropriate departments, and then the more we quickly distribute the data or share the data, more we get rid of this COVID-19. Okay. I think that concludes it. Any questions?
Rajan?
Yes, sir.
Thank you for your session. I have a list of questions asked from the chat bots.
Sure.
Let me come out with the first question. How many clients can access the server at a time? How can we achieve the fast data transfer? This is the first question raised by a educator who has asked this question. How many clients can access the server at a time? How can we achieve fast data transfer?
Very good question. Very good question. So, as I mentioned in these the enterprise service bus, the blueprint. See, you have a load balancing. So there are like a high availability and then load balancing. You can add any number of servers anytime. So nowadays, these enterprise service buses are available on the cloud computing also, like Amazon or Google or Azure. So they have a pretty good enterprise service bus which can be auto scaling. What does that means is like infinity. So whenever you can set up the auto scaling. So let's say if I reach 70% threshold, for example, I'm expecting 1 million or maybe 100,000 transactions per second, or I have a vendor of 100,000 vendors. If I reach that in a certain threshold, automatically spin a new server. So with the cloud computing, cloud computing is a beautiful one. Now I'm admiring like anything. You can scale like crazy. Automatically it scale, and let's say it if the volume is reduces, it will automatically bring down the server. You don't need to do anything manually. Everything is automated. So with the cloud computing, you can keep on add as many you want. You want to process 1 million in a day. I mean, if you want to do 1 million in a second, you can scale it to that core. And then the faster data transfers, again, is all on the between where you want to transfer the data. So if it is a cloud to cloud, they have a lot of way to connect the cloud and then transfer the data. So if I have to upload the data through the like a file transfers, it will take time. But most of these REST API and all, those are not going to take time at all. The REST API's execution times are less than like 100 milliseconds and 200 milliseconds.
Very good. Very
so good. That is pretty good execution time.
Okay, GTR, let us not think about it going to infinity. Let us reduce the rate of COVID to a larger extent. Let it not win, and let us not bother about fast data transfer. This is a set of questions technically being asked. That's what I asked you.
Right. So we can actually, to answer to that, I mean, it depends on the requirement. You can automatically set that one. So there is no limit for this.
Yeah, the next question is, they asked if any attributes are newly added or modified. Any issues happen in the client side, they are asking. If they are going to, any attributes, I don't know in which part.
That is a real good question. Okay. So I was keep on talking about the JSON format, right? So the JSON format is a very good format that I came across recently there. So the JSON format, which we talked about that this one, right? So let's assume that I'm going to add additional values or additional attribute to these patients. Then I don't need to worry about that. If rest of the, for example, if 10 system is consuming this data, and then I add address, okay,
Okay.
10th Street.
The next question is, okay, proceed.
Yeah, with this attribute, the parser can ignore. You can set the option called if there is a new attribute comes in, or if it is not in that, you can set the ignore, so that whenever they can add more, and it's up to the individual application to add that attribute anytime they want it. Until that data will come in, but if you are not consuming it, it will stay as it is. So that's the beauty of the JSON.
Okay. Do you have any method to overcome redundant data entry?
That's also a very good question on this. So redundant data entry is very common to that, because when some within the street itself, they are very proactive. They will send the same.
More people will be reporting.
Sorry?
More number of people will be reporting that.
Yeah, more number of people will reporting to that. So what we can do is, in this, before I write this data, I will do some kind of lookup and also do a pattern matching. So those are all very important. I think you all study the pattern matching algorithms.
Yes, in AI, artificial intelligence.
Yeah, so we can add those kind of logics to this, so that it will identify and then it will mark it as like redundant data.
Okay. Another question, GTR. Do we have any standard template for using this enterprise service bus? Standard template?
Yeah, that's a very good question. So it depends on the vendor. So for example, IIB, this is like IBM's bus. So they call this as a templates, the message queue and then input and output. They call this also as a template, and whatever is in this palette, those are all called as the template also. For example, if the REST API has to be created, then there is a template available using a Swagger. So you can use the Swagger templates to create the REST APIs. All you need to define is, this is the sample templates they will give. It's called YAML. There you can specify what is your response is going to be and what is your input is going to be. So for each palette, whatever you are seeing in that palette, you can see the appropriate templates for that.
Okay. One more question. Do you have any specific filter or sorting in HTTP request? Can I add a specific filter or sorting in a HTTP request?
Yes, you can do that. Actually, in the HTTP request, let me show this one. So, I have the header. If I want to add the HTTP header, I can add that to the filter here. Okay. Or this is like addition to this. And then they also have a that's the rest. It's a routing. Okay, route to label. So I can define a label here, and then I can add the filter, Whatever that filter you want to add it, you can add the filter and then label it and then pass it to that route to the label. So you can have one HTTP, and then by using the URI's last node, and then you can filter it and then send it to the appropriate labels. And then you can write your own process for that label.
Okay. GTR. Finally, one more question. How many are open source? How many we have to spend from our pocket for establishing a enterprise service bus architecture?
Yeah, that is actually, I would say it depends. Some of them are the MuleSoft, they call it as a open source, but if you see that if you need any support on that, it's very expensive. And IBM Integration Bus for development, let's say if college wants to teach this integration service bus, it's free. Easily you can download it. And you cannot use it for like any software, the production usage. But for learning or developing, you can use the IBM Integration Bus. That's a free. And then Web Methods Integration Server also, it's kind of like open source only. There's an Oracle Service Bus is not open source, and Red Hat Fuse is having an open source option using the Apache. And then Talent is also, it's like an open source only.
Postgres also you told open. Postgres also you told us open source.
Postgres is a database. Yes, that is the open source. You can freely download. That's why I'm using it. And then IBM Integration Bus also, it's like a developer version. I can send the downloadable link so that you can download it and you can try that also. It's free only. Until otherwise, if you are not developing and selling it, then it's a free license for that. It's a developer license, and you can develop it and then learn it. That's where the IBM Integration Bus is. And if you need, I can send that link to download it. Again, MuleSoft is also, they call it as an open source, but their subscription model is when you go for any support, then it's going to be, it's a price for that.
Okay, Tirupati Rajan, that's a list of questions, and hopefully you answered all the questions to the satisfaction of our educators. I am formally moving on to the vote of thanks. I make my vote of thanks to start from the beginning. Our alma mater, VHNSN College, our college management, our beloved principal, Dr. P. Sundarabandyan, who has been encouraging us to promote such type of activities throughout this pandemic period. We have been conducting larger amount of webinars. Heartfelt thanks to our beloved principal, Dr. P. Sundarabandyan. And the next thanks goes to my beloved head of the department, Dr. Kadirwala Kumar, my PhD guru, who has been foremost in making qualitative improvements in our campus. Man was very keen on quality, rightly being the IQAC coordinator, was encouraging us to conduct such type of brainstorming activities to give new inputs to not only to students but also to the stakeholders of our institutions. I thank our department, Prem Kumar. This person rightly need larger amount of applause. Since this is a logical meeting, we cannot put our hands together. My heartfelt thanks to Prem for to have rendered a very big service to our institutions in this pandemic period. Surely he must have engaged himself in 30 or 50 such type of webinar constructs and being a very big technical support to us, making this webinar programs a very successful one. And our technical support staff, thankful to our technical support staff in our institutions. And foremost goes to our laudable alumni, GTR. We fondly call him as G. Tirupati Rajan. GTR is his short name, who has been associated with him from 1987 to 1990 onwards. 30-year relationship he is having with this department. every year, every month, he verifies what is going in VHNSN. Very fond personality, very lovable personality, and a kind-hearted personality sponsoring larger amounts to the welfare of Department of Computer Science and School of Computer Science. I don't want to list out his sponsorship, it will go to pages. Thank you, GTR, for being very kind enough to have accepted our offer. During this night time in America, you are being interacting with our persons, taking into consideration, this is the morning session that we are starting from here. Very, very big thank you to you. You are very powerful. I would like to establish to the educators, right from data to reports. So slowly want to give a glimpses of what he has taken. Right from data structures, he has given us an idea about how this enterprise service bus architecture for COVID-19 data exchange is now a very big backbone for us in this pandemic period. This pandemic period, everyone is worried about what is going to happen. What is going to be the fate of that? But we need an exact architecture that fulfills our needs, that fulfills our desires to make this pandemic move away as soon as possible. But how can it be made to move away from this society? Can be with the help of all ourselves. We should know what is happening in the background. Like in India, we are having Arogya Setu app. This Arogya Setu app is also must be running with such type of enterprise service bus. He has given a lot of ideas in this enterprise service bus, quoting REST API, JSON, Ruby, Python, all giving instant, immediate response. And I have taken down larger amount of technologies that is going behind this. Yes, this enterprise service bus integrates larger amount of software, hardware, security, and a lot of latest technologies being into this. I could find artificial intelligence also to be included largely into this discipline. Thank you very much, Tirupati Rajan, for to enlighten this audience with the hybrid technologies being put together, right? Starting from data to reports. You started from data structure, finally ending with reports, and also made us to interact with you with some emails and other things. Really a lively session that everyone should have enjoyed, and terminologies made known to every one of us. This and time for you, you have interacted with us. Thanks a lot. Thanks to our college management and Dr. Kadirullah Kumar to have done this job. Once again, heartfelt thanks to GTR.
Thank you, sir. Thank you, Principal and TK sir, for giving me the opportunities. Anytime, this is my passion, and whatever I know, I'm ready to share it with you all. So it is my passion. So I don't mind even it's 3 a.m. or 4 a.m. That's fine. But again, once again, I thank the management and principal and TK sir and you all who have joined this one, and hope enjoy this session. And
surely they have enjoyed a lot. They must have enjoyed a lot of demonstrations has been given. They should have really enjoyed it. And once again, we thank all the participants around the world to have participated in this very good session organized by our college. Thank you, Tirupati Rajan, and the participants and educators.
Thank you.
Bye.